Hi, good evening. We continue today with another relatively advanced and relatively technologically mature aspect of contemporary learning systems: the technology, memory models, and the adaptivity it supports, memory optimization, and spiraling review. Quick quiz for all of you. What is the capital of Pennsylvania? I'll freeze here for 20 seconds while you think of the answer. So you probably learned this fact at some point. Some of you might immediately remember this. Some of you might remember this, but it took a couple seconds or longer. And some of you might not remember this at all. Next quick quiz. What was the name of your first grade teacher? I'll freeze for 20 seconds while you think of the answer. Man, I'm bad at that. Curious thing. Forgetting involves both being unable to recall and being slower to recall. And even more curious, how likely you are to remember something depends on how many times you've encountered it, how long ago you first encountered it, and the spacing between the times you encountered it. The human brain's a funny thing. And this is what memory algorithms usually depend on. But this actually isn't a complete account of how memory works. There's a couple of other key phenomena. One of them is spreading activation. Spreading activation is the idea that when you think of something, facts related to it also get activated in the brain because you might need them. And so, as a result, if you want to try to remember something, try to think of as many things as possible that are related. If you can't remember somebody's name, think about when you met them, think about the names of people who introduced you, who you talked to in common with them, think of scientific papers they're on. All of that will increase the activation and suddenly you'll remember it. Another key phenomenon in memory is chunking. Chunking is the idea that we can only remember so many pieces of memory at a given time, but if we know something as a chunk, if we know something as just a unit in itself and it has multiple components, we can actually remember that chunk. An example of that is phone numbers, back when we used to use those, like 610 or 215 or 412. Those are all Pennsylvania phone numbers. There's another great story about this that I'd like to share with you. It's a story about the famed scientist Herbert Simon, who, if you haven't heard of him, he was one of the most famous and important scientists of the 20th century, published in all kinds of fields. And among other things, he was a key figure in cognitive science and in artificial intelligence. And Herb, one day, the story goes, was teaching his cognitive science class, and it was the day of the final exam. And everyone's working because it's a really hard exam, but there's this one student just sitting there, like hitting themselves in the head and looking upset. And 20 minutes passes, 30 minutes pass, 40 minutes pass. The exam time's almost over and the student still hasn't written a single thing. And finally Herb can't stand it anymore and he walks over to the student and he says, "What are you doing?" And the student says, "Well, Professor Simon, I studied for your class the way that you taught me based on the idea of how the human memory works. And what I did was I took every single lecture that you had and I wrote down every idea in it. And then I clumped those ideas into subthemes. And I clumped the subthemes into themes. I'm using your chunking idea. And then I took those themes and I put them into overarching themes. And finally, I took the overarching themes and I chunked them into one word that I knew completely summarized your class. Because I knew that if I could remember that one word, I could remember everything." And Simon looks at him and goes, "Bullshit." And the student says, "Thank you." Spreading activation and chunking are not usually used in memory optimization systems, but they really help, and you should use them in your daily lives. So let's talk about the principle of spaced repetition. The idea here is that when you cover a subject, you want to cover a subject in a way that's spaced out. Optimal repetition is spaced out. If you study something in a very focused way, you remember it for a short period of time. That's why cramming is really good for doing well on the test and really bad for using that knowledge ever again in your life. So optimal repetition is spaced out, and furthermore, optimal repetition has increasing intervals. If you study something at even intervals, The early ones will be too long, you'll forget it, and the later ones will be too short and you won't need it so frequently anymore. So there are several algorithms for memory calculation that are used for optimal spacing. And some of them include ACTAR, MCM, Settles and Meters algorithm, DASH, and the completely unpronounceable DAS3H. People usually pronounce it as dash 3H, which really makes no sense but is least pronounceable. There's a lot of variation and complexity in these formulas. It really runs the gamut. Some of these formulas just take the number of times the content has been successfully and unsuccessfully remembered, the time since seen, and the item difficulty. Settles and meter. That's actually used in Duolingo. Other ones are more complex, and they use exponential or power function decay of memory of each exposure to content until now. So they keep a record of every time you've seen an item or a fact and do these really complex calculations on them. And by the way, exponential decay or power decay, a heated argument that for now like 40 years some cognitive scientists really care about. Don't get into a dark alley with some of these folks and say you believe in exponential decay. It will not go well. The key intuition of all of these, from simple to complex, is that memory activation drops, somehow, over time. When memory activation is higher, response time is both faster and accuracy is better. You're more likely to remember it, and you're more likely to remember it quickly. And for some mathematical details, see this lecture, which actually goes into all the math details. That's not what this class is about. Now there are other algorithms that don't explicitly calculate memory used for optimal spacing, and most of these are a little older. They include the Pimsleur method, if you've ever taken a Pimsleur language course, that used that. The Leitner system, used for flashcard apps. SuperMemo, used in Anki, I love Anki. Quick tables, used in Alex and adaptive flashcard programs. And pretty much every ad hoc spiraling review algorithm. Wang and Heffernan talk about this in the context of assessments, but teachers have been using ad hoc spiraling review algorithms since the 1950s in class. For example, Pimsleur, Leitner, and the original SuperMemo had a predefined schedule for practice. If you make an error, you go back to the beginning. And Pimsleur and SuperMemo were based on time. Leitner was based on the thickness of partitions in a deck of index cards. To use the Leitner system, you actually had to buy these special cards in a special box to keep them in, which, made a lot of sense in the 1970s. SuperMemo 2, which is the version used in Anki, adjusted the schedule for practice based on the item difficulty for the current student. In other words, it learns over time that this is an item you struggle with, and this is an item you don't. But still, if you make an error, you go back to the beginning. Quick tables had a predefined schedule for practice. Every time you get the correct response, you move forward one table. It's kind of like the partitions in Leitner. And if you make an error, you go back one table. So you don't go back to the beginning, you kind of get a shorter interval. So unlike SuperMemo and Pimsleur, you don't go all the way back to the beginning, but you get a shorter practice interval. In terms of information storage, ACTAR and MCM and dash 3H calculation require examining every past encounter with the item, or for dash 3H, the items involving the current skill even, every time you calculate memory. SuperMemo 2 is much simpler. It just requires storing the number of correct responses in a row, the item difficulty for the student, and when their last practice was. Quick tables just require storing an item in a table. As you can probably guess, it's the theme of our semester, simpler algorithms are used more than the more complex algorithms in real-world systems. Duolingo uses Settles and Meter, Anki uses SuperMemo, Pimsleur uses Pimsleur, and even simple spiraling review works. It leads to better retention of knowledge over time. That's why these simple algorithms still get used at scale. They're easy to implement, they're easy to understand, and they work. So why isn't it used all the time? Why do most adaptive learning systems not use memory optimization? We know it works. Well, for one thing, it's because it is emphatically not fun. Siebert, Hansen, and Brown talked about how non-fun memory optimization and spiraling review is. Now, Duolingo does seem to fix the fun problem, right? It's a gamified system. We'll talk about gamification later in the semester. Duolingo does seem to solve the fun problem, despite doing an activity that is inherently non-fun. But it's also worth asking, is Duolingo enough to develop fluency? It's fun and optimizes memory of vocabulary, but do people actually learn to speak fluently from Duolingo? The last several years, when this class was taught live, every year I asked my class who's used Duolingo and who got fluent from using it. And the answer is that almost everybody has used Duolingo. and no one has gotten fluent from it or even heard of anyone who got fluent from it. But that said, sometimes memorization really is good enough, like in studying for medical certification exams, because you're not going to want to be able to know or use that knowledge afterwards. And memorizing vocabulary is clearly part of learning a language. And spaced repetition can even be useful in remembering skills like mathematics problem solving. So, memorization and spaced review is good, it's just not enough. And by the way, sometimes you're going to skip some of the readings in this class. I know what happens. Don't skip this one. It's fun, it's interesting, and it's entertainingly not humble. It's well worth reading Pyotr Wozniak's writings. They're quite entertaining. So some takeaways. Forgetting involves both being unable to recall and being slower to recall. Spaced repetition helps you remember. But spaced repetition apps are, however, except for Duolingo, no fun whatsoever, and they're not enough.